Okay, so the next thing I want to do is I want to find the equation for a line that's parallel to another line going through a certain point. Okay, now sometimes it might be kind of difficult because it's hard to find the original slope, but in this problem it's actually going to be pretty easy to find the original slope because we just have to look at it because it's already in slope-intercept form. So your steps are going to be to find the original slope, and the slope of your new line is going to be the same, so you can skip right to the next step, which is to find your new b value, and b is your y-intercept. Okay, so if I look at this first example, my original slope is m equals -1/3. In fact, maybe you even want to label this m orig, put like a little ORIG there, m original, a little subscript there. That doesn't mean Morig. I think Morig was like some guy from Lord of the Rings or something, was Morig, but this means m orig, it means original slope. And my new slope, I can call it m sub new, which doesn't mean m new, that doesn't mean that. My new slope's going to be the same as the original slope because they're parallel lines, okay? So my new slope is -1/3. And I'm going to write that down, y equals -1/3 x plus b, and then I'm going to try to find the new b value. Whatever b value I have has to cause this line to go through the point 6, 8. So if I plug the 6 in for x and the 8 in for y, I can figure out what b has to be. And we've actually done things like that before, where we've had the slope and we've had to find b. So I have 8 equals -1/3 times 6 plus b. And if you multiply this out, you could use your calculator if you want. I get 8 equals -2 plus b. And if I add 2 to both sides, I get b equals 10. Okay? So my y-intercept for my new line is 10. And you know what we could do just to make sure that everything worked out okay? I'm not going to do this all the time. We could actually graph this one and see what it looks like. I'm just going to do a really rough sketch here, but just to make sure. So my original line started at 7. 1, 2, 3, 4, 5, 6, 7. And you don't have to graph this. If you just want to watch me graph it, that's fine. And I go down 1, right 3. Okay. And my new line is supposed to start at, well, I guess it starts at 10. So 7, 8, 9, 10. And there's my new line. I go down 1, right 3. And we can definitely see those two lines are parallel, except I kind of didn't do a really great job of drawing them, but other than that, they would be. And then supposedly the point 6, 8 should be on this new line. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. So right there, yeah, it looks like the point 6, 8 is on my new line, just like what I wanted to happen. So I guess we did it right, and I'm going to shrink this graph down and move it over there so we have room to do the next problem. Now the next one I'm not going to graph, I'm just going to do it, okay? So my original slope, I don't have to put it in slope-intercept form, it already is, and I can see that my original slope is 2. So m orig is 2, and then m new, not manu, it's m new, is also going to be 2. My new slope is 2. So far, this is what my new line will look like. It'll be y equal 2x plus b. And I'm going to take the x and plug it in there. And I'm going to take the y and plug it in there. And then we solve for b again. So I have -1 equals 2 times 4 plus b. 2 times 4 is 8. Whoops, that negative kind of got messed up. And then I subtract 8 from both sides, and I get b equals -9. So now I know my y-intercept. The last thing I need to do is write the equation. So it's y equals 2, my slope is still 2, x minus 9. And there we go. That is the slope of a line that is parallel to the original line, but going through different points than this one goes through. Okay? So hopefully you found that helpful, and we'll do some stuff with perpendicular line, and then we'll be done.